Checking a solution. Example 1. Lenny is calculating the resistance of the starter motor when cranking the engine. The current measured is 240 amps. Battery voltage is a 12 volts. Using the equation below, Lenny got 0.05 ohms. Is this correct? So we're checking to make sure the calculation done gives us the resistance of 0.05 ohms. So we have 12 volts and we have the current at 240. So what we have is we have these two pieces of information. And how we're doing it is we're checking to make sure that it's equal. So if we go 12 over 240, does it in fact equal 0.05? So we're asking, is this true? So how we can do that is we're going to go ahead and divide 12 by 240. So here we have 12, and we're going to divide it by 240. Now we know we're going to need some zeros. So 240, we look to see if it can go into the first number, and it can't because 1 is much smaller than 240. It can't go into 12. It can't go into 120 because even 120 is still smaller than 240. But it could probably go into it 1,200 times. So because we're kind of going to guess on that number, we're going to go 240 times 5. So 0 times 5 is 0, 4 times 5 is 20, carry the 2. 5 times 2 is 10, plus 2 is 12. So I didn't go into these numbers, but 240 times 5 is 1,200. Then we subtract and we get 0. So we would say that this is correct, that Lenny did the correct calculation and got the correct answer. So this is correct. So let's look at another example. Example 2. A 12 volt circuit has a resistance of 8 ohms. We found the current to be 2 amps. Is this our correct solution? So how we do this is we have voltage and we have resistance. So we are looking to see when we go voltage divided by resistance, does it give us 2 amps, which is our current, which is I. So how we do this is we're going to go 12 divided by 8, and does this give us 2? So is this correct? So how we do this is we can go 12 divided by 8. Now, 8 can go into 1, but it can go into 12 one time. So we have 8 times 1 is 8. Subtract, we get 4. Then we add a decimal, we add a 0. We're going to bring that down. We're going to add that decimal up there too. Now 8 can go into 40 5 times. We subtract, and we get 0. So our current actually should be 1.5 amps. So this is not correct, as 2 amps is not the correct answer. So let's do one last example. Example 3. Is x equal 4 the solution to? So here we have negative 3x plus 6 equal to 1. And we're asking if when x becomes 4, when we substitute in x as 4, does these two sides equal to one another? So we're asking, is 1 on both the left-hand side and the right-hand side to make it true? Because it has to be equal, because that's what the equal sign says. So we have minus 3, and then now we're going to put in 4. And then we're going to add 6 equals 1. So we have negative 3 times 4, which is actually negative 12, plus 6 equals to 1. Now negative 12 plus 6 is actually equal to negative 6. And you can see that negative 6 on the left-hand side is not equal to 1 on the right-hand side. So this is not correct. So we found that this is not the correct solution, as x is not 4, because it does not make the both sides to be equal to one another.